So now we're going to do recursive binary search trees. And what we're going to start out with is contains. And we did this in the other binary search trees section. But when we did this there, we did it iteratively. And now we're going to do it recursively. So we're going to start it out like this. And with the other contains method, we only passed it a value. We did not need to pass it a node. And that's why I have the double underscore in front of this for the recursive contains, because we don't want the end user to call this directly. What we're going to do is we're going to have another method called rContains for recursive contains that does not have a double underscore. And with this one, we just have to pass it the value. And then we pass that down to here and call the double underscore recursive contains with the root and that value. So I'm going to remove this second one and we'll build out the top one for this video. So now let's code for our first situation. That is when we have an empty binary search tree. In this case, we're going to say if current node is equal to none, and that is the case here, we pass this the root, and the root is none. If that is the case, we're going to return false, because that means that the value that we're looking for is not in the tree. But now let's say we're looking for the value of 47. In this case, the value is in the tree, so we're going to say if the value that we're looking for is equal to current node.value, we're going to return true. Where this becomes a little bit more complicated is if we're looking for the value of 21. So now this is not at the root. So now to walk through this, I'm going to bring up a call stack and I'm going to add an instance to the call stack. And that instance is being called on the root node to begin with. And then also I have this 21 underneath because that's the value that we're looking for. So we'll say if the value that we're looking for is less than current node.value, and it is, we're going to return rContains, and this is where it's recursive, and we're going to call it on current node left, and we're also going to pass this that value that we're looking for. So now we'll add this to the call stack. And now this is the active instance. So we'll start at the top and say if current node is equal to none, and that is not the case, and then we'll move down to here. And if the value that we're looking for, 21, is equal to current node value, and it is, we're going to return true. And it's going to return true to this instance. And once it returns that, this is popped from the call stack. So this is the active instance again. And this is where we left off in that instance. And this part of this line is what called the instance that we just popped off the call stack. So when that instance that we just popped off returned true, it returned it to here. So you can see that this has a return statement. So where does this return this to? It's going to return it to here. And specifically to this part here, because that is what called this instance down here. So it's going to return true to here. And when it does that, this gets popped from the call stack. And you can see that this has a return statement as well. So where does this return it to? It's going to return it to the original method call when we said we were looking for the number 21. So it'll return it to here. So that's how it works if the value is in the tree that we're looking for. If it is not in the tree, let's say we're looking for the number 21 again, let's walk through how that would work. So we'll put an instance of rContains on the call stack called with the root, and we're looking for the number 21. And since 21 is less than 47, this if statement is going to apply. And in this case, current node.left is none. So we're going to call an instance on none. So now this is the active instance on the call stack. So this is going to start at the top and say if current node is equal to none, and that is the case, we're going to return false. And it's going to return false to here, and this gets popped from the call stack. So now this is the active instance again. This is where we left off, and this code here called that instance that we just popped off. So when it returned false, it's returning it to here, and this in turn will return false to this method. It will return it to here, and when it does that, this gets popped from the call stack, and this will return false to the original method call. So we do need to add one thing to this method. This code here traverses left. We also need code for traversing right, so we'll add this. This part here could be an else. I just think it's a little bit more readable to do it this way, and for teaching purposes, I like to make the code as readable as possible. And remember, we don't call this method directly. We kick all of this off with this method here. So we'll look at this code in a moment in VS Code, and when we do, we'll build this binary search tree, and we'll run r contains on 27, and that should return true. And then we'll run it again on the number 17, which would be here if it was in the tree, but it's not, so that should return false. So now let's flip over and take a look at this. So there are the two recursive contains methods that we just created. And I'll scroll up, and this creates that binary search tree that we just saw in the diagram. And here we're going to run r contains on the number 27 and the number 17. And I'll run this. And you can see up here that with the number 27, it returned true, and with the number 17, it returned false. So it looks like we have a working method for recursive contains.